Thank you for choosing Bristol Compressors as your replacement solution. In today's economic environment, the new norm is that consumers are more discerning in their spending. As a result, many homeowners are choosing to replace a compressor instead of a complete system replacement. As you know, the most competitive bid usually wins the job, and there are several reasons why replacing a compressor can be the best economic decision. Compressor changeouts require less labor. One technician can change a compressor. Instead, 2 or more are required for a system changeout. Changing out a compressor doesn't require any structural changes to the home. With new systems, often the line sets must be replaced, and indoor air handlers may require additional space. Changing out a compressor saves time and money, and gets you to the next job faster. Replacing a compressor using Bristol's Retrofit Assist Kit requires only minor tube changes and reduces wiring modifications. This short instructional video will help you replace the compressor in a safe, effective, and efficient manner using a Bristol Compressor's Retrofit Assist Kit. Some minor tube modifications may be required. When working with electricity and refrigeration of any kind, safety is key. Please make sure to follow all safety procedures, including lockout of all power sources and the use of protective clothing, such as safety glasses, safety-toed shoes, and gloves. The first step is to disconnect the main power source and use a lockout device. Confirm the power is off by checking at the line side of the contactor with a reliable voltage tester. This will ensure that all source electricity is off, and it is now safe to proceed with replacing the compressor. After the original compressor has been tested and found to be defective, the system's refrigerant must be recovered. Before you start the recovery procedure, an acid test can be taken. These kits are available at your local distributors. A certified technician must follow all EPA guidelines when recovering or charging refrigerants. Once you have recovered the refrigerant, it should be weighed to ensure the system had the proper refrigerant charge. Incorrect refrigerant charges will cause premature compressor failures. The next step is to disconnect the wire terminals from the failed compressor, noting the wire terminations, such as common, start, and run. Now it's time to remove the defective compressor. Once you have removed the defective compressor, remove the oil and pour into a measuring container to check for proper oil charge. The reason is to ensure there is no remaining oil in the system. The correct oil charge for all Bristol products can be found on our website at www.bristolcompressors.com. Next, you want to perform a visual check to ensure the oil is free of contamination. If contamination is present, a suction line filter is required. Here, you should also perform a second acid test. If the acidity level is above 0.05, acid away should be added to the replacement compressor prior to installation, according to the manufacturer's specifications. Always install a liquid line filter dryer when the system is open for any reason. Remove the existing filter dryer using a tube cutter when possible. All old filters must be removed and disposed of properly. The next step is extremely important. In this step, you must replace the components that cause the compressor to fail. A secondary part failure, such as start components, contactors, or loose connections, could actually be the cause of the primary failure. Make sure to inspect all compressor components and make any necessary repairs. Now it's time to install the new compressor utilizing a Bristol Compressor's Retrofit Kit. If this is a heat pump without an accumulator, the TXV thermal bulb should be removed from the suction line to prevent overheating. Once the compressor is mounted securely and suction and discharge tubes are connected and brazed, a new suction line filter, if required, plus a liquid line filter dryer should be installed. This should be a bi-flow if for a heat pump. If the discharge line is found to be contaminated, the metering device should be cleaned. Also, if the system is equipped with a screen filter, it should also be cleaned if contamination is present. The screen filter will be in front of the metering device orifice point. As a precautionary measure, always make sure you are installing the correct starting components. Never assume the original capacitor is the correct one. It is extremely important to use the capacitor recommended by Bristol Compressors. You may check our website at www.bristolcompressors.com for the correct components. All compressors built in 2010 and after will have the run cap identified on the compressor's code plate. The next step is to replace all starting components. Please note, if the reciprocating compressor is used to replace a scroll in a system equipped with a non-bleed TXV, a start capacitor and start relay will be required. If using the H22J series as your replacement, no start capacitor or relay will be required. Only an external discharge check valve is needed. Example, H22J25BABCA. The B represents an internal bleed. For more information, refer to Application Bulletin 140 on the Bristol website. Bristol Compressor does approve Kickstart. The correct Kickstart information can be found on the Bristol Compressors website under Marketing Bulletin PMB-97-006B. Using dry nitrogen at this point, you should perform a preliminary leak check. For optimal performance and reliability, Bristol Compressors recommends a triple evacuation procedure using a reliable vacuum pump with clean oil and a micron meter. Evacuation should be conducted simultaneously from both sides of the system with valve cores removed. This can be accomplished using the proper tools available from your local distributor. Pulling a vacuum through valve cores will require additional time to perform proper evacuation. You should use the shortest and largest diameter hoses available. Pulling through a restricted line will provide a false vacuum reading. First, you should evacuate the system to 1500 microns, and then break the vacuum with dry nitrogen to a pressure of at least 3 psig. In the next evacuation, you should evacuate the system again to 1500 microns and break the vacuum with dry nitrogen again to at least 3 psig. Finally, evacuate the system to at least 500 microns. Next, blank off the vacuum pump and watch the micron meter. If a leak or moisture is present in the system, the microns will start to increase. If this happens, correct the problem and repeat the evacuation and prepare to charge. When the system is off and in a vacuum, you can now weigh the refrigerant as a liquid on the high side only. The system should also be leak checked again with the electronic leak detector. All panels are now ready to be reinstalled to ensure proper airflow. The remaining charge should be metered in slowly to the low side. Now, perform a check to ensure that superheat and subcooling are to specifications. There is equipment available at your local wholesaler that will automatically calculate the superheat and subcooling, or you can calculate it manually using a pressure temperature chart. Once the charging hoses are disconnected and service caps reinstalled, fittings should be leak tested to ensure no leaks using the electronic leak detector. Thank you for choosing Bristol Compressors. As a good representative of your company, always make sure to clean up your work site and secure all tools and supplies. A properly installed Bristol benchmark compressor provides the homeowner with many years of quiet, reliable service. Bristol Compressors wishes to thank the manufacturers for providing the tools used in this production. For more information, visit our website at www.bristolcompressors.com or call 276-466-4121. Bristol Compressors products are 100% built in the USA.